When we take matter and change it, there are one of two things that can happen. If we change a substance such that one or more new substances are formed, and these new substances have different characteristics than the reactants we started with, then this is a chemical change. The fundamental identity of the substance has been altered from before the change to after the change. Examples of this would be when we burn something or when combustion takes place. Combustion or burning is the rapid oxidation, the rapid combining of a substance with oxygen to form a brand new product. Digestion of food in the stomach is an example where the individual molecular structures, chemical compounds, are broken down and formed into different molecules that the body can absorb and utilize for its functions. Fermentation, whereby sugars are chemically reacted to form alcohol molecules. All of these would be examples of chemical changes. Physical changes, by contrast, are changes in which the chemical identity of the substance does not change. Examples would be if you pounded a piece of clay into a flatter piece of clay. It's still clay. Pulling something. If you draw a metal into a wire, draw a piece of copper into a thin wire, you're not changing it, it's still copper, you're just changing its form. Same thing with cutting. Cut a piece of paper in half. It's still paper made of cellulose. All that's changed is its form. Changes of state are a physical change process. When we change from a solid to a liquid, or a liquid to a gas, or anywhere there in between, we are not changing what the substance is, we're simply changing the orientation of the individual molecules or particles to one another. And the classic example to think of here is water. If you take an ice cube, that's water, H2O, in the solid phase. If you allow it to sit out or you heat it up, that ice cube melts into a liquid puddle. It's still water, it's still H2O, it's simply in a different state, a different form. The molecules are a little bit more free to move about one another, and so they form into that liquid state. If we heat that liquid water even further and change it into a gas, steam, water vapor, is still water, H2O. It's simply that now the molecules have even more space between their molecules and even more freedom of movement. So the chemical identity of the substance, the water, hasn't changed. It's just the arrangement of the individual particles that has changed. Properties are ways that we can describe the behavior of a substance that's undergoing a change. And so physical properties are going to describe physical changes of a substance, whereby chemical properties will describe the ability of things to undergo certain chemical changes. If we take the chemical changes that you see here and determine the corresponding properties, if the chemical change is that it's going to react with another chemical, the way we describe that property is the reactivity of a substance. If we're going to measure the ability of a substance to burn, then we're talking about its flammability. To describe the tendency of something to decompose spontaneously, we would refer to that property as stability. Physical properties correspond to physical changes as well. So when we talk about the ability to pound something into a sheet, we refer to that as that substance's malleability. If we want to draw a substance out into a wire form, that's known as ductility. If we want to change a substance from its liquid form to its gas form, that's referred to as boiling. If we're adding heat, we're getting to the point where the vapor pressure is going to equal atmospheric pressure, so we get boiling. The temperature at which that boiling occurs is known as the boiling point. So boiling is the change, boiling point is the physical property, the temperature at which that occurs. Changing from a solid to a liquid, that process is known as melting, so the corresponding temperature at which it occurs is the physical property of the substance and is known as the melting point. Within the classification of physical properties, we can further break it down into two more classifications: extensive physical properties and intensive physical properties. Extensive properties are ones that depend upon how big your sample is. How much of that matter, that substance, do you have in front of you? Examples of this would be mass, length, and volume. Intensive physical properties are ones that are independent of how much matter is actually present, how big your sample is. These properties don't change whether you have a tiny minuscule amount or a huge abundant supply. And so because they are independent of how much you have, they are very useful for identifying substances. When we watch shows like CSI and we talk about forensic scientists, these are the sorts of properties that they mainly depend upon in identifying evidence and materials that they might find at a crime scene. Examples of intensive physical properties would be things like density, malleability, ductility, the melting point, and the boiling point of a substance.